Bismillahirrahmanirrahim. Now we are going to discuss topic 2.8 OS structure. The OS structure has two types, non-modular, which is also known as monolithic structure, and modular approach. For non-modular, it is similar like programming, where we put all our code in main function, while for modular approach, we divide our code into several functions and we invoke that function from main function. So for modular approach, it has two types, which are layered approach and microkernel approach. We start with monolithic structure. So actually for monolithic, it has no structure. All functionality is provided in single binary file that runs in a single address space. So even though this system are difficult to modify, so here it's mean that the term refer to this problem is tightly coupled system, where if we modify one part in monolithic structure, it will affect wide ranging component. It will affect other component. However, they have a primary benefit, which is efficiency. So why it is efficient? Because all kernel code and data structure are kept in single address space. Thus, no context switches are necessary when a text call or when a hardware interrupt is delivered. Secondly, because kernel can pass data and make requests using C function invocation rather than using complicated inter-process communications. So in microkernel structure, the communication using IPC. So this single address space contains all kernel codes, including device driver, file system, and networking code. So this structure has been adopted by original Unix. Original Unix consists of two separable parts, system program and the kernel. So system program, this is the system program. It has shell and commands, compilers and interpreters, and also system libraries. While the kernel, it is situated below system call interface, and above kernel interface to the hardware. So this is the kernel. It's provide the file system, CPU scheduling, memory management, and other OS functions. Another OS that also adopt monolithic structure is Linux. So Linux has monolithic plus modular design. So modular means it's can be modified during runtime. So we will discuss modular structure after this video. So for Linux structure, it has application software here, where it has the system library, then system call interface. Below the system call interface, it has the kernel. So inside the kernel, it has file management, CPU scheduler, memory management, and also others OS functions. The second structure is layered approach. So in this approach, OS is divided into several layers. So each built on top of lower layers. Higher layers built on top of lower layers. The bottom layer, which is layer 0. So this is layer 0, is the hardware. And then followed by layer 1, layer 2 until layer n. So the highest layer is the user interface. So OS layer is an implementation of abstract object that made up of data and the operation that can manipulate those data. OS layer consists of data structure and a set of functions that can be invoked by higher level layers. So in turns, So for example, we have layer M. Okay, so layer M, let's say it's situated here. So layer M can call layer 1, okay, lower level layer. Layer N can call layer M. Okay. So this approach used in computer networks and web applications. The advantage of this approach, number one, loosely coupled system. So this is contrast with tightly coupled system in monolithic structure. So loosely coupled system means if we modify any components of the kernel, it will not affect others component. This approach simplifies the debugging process. Okay, this is how it simplify the debugging process. So let's say the first layer can be debugged without any concern, okay, because the bottom layer, the lower layer from first layer is hardware. Okay, so it's also uses only the basic hardware. Okay, so we assume that it has correct the hardware has correct functioning. So once the first layer is debugged, okay, its correct functioning can be assumed, okay, because previously we assumed that hardware must be in the correct functioning, okay. While once the first layer is debugged, okay, and then we assume that it has a correct functioning, while the second layer is debugged. Okay, so if error is found during the debugging of a particular layer, so the error must be on that layer only, because the layer below it already debugged and it is has correct functioning. Okay. The disadvantage of layer approach, we need to appropriately defining the functionality of each layer, because we have to make sure that the higher layer can use the function of lower layer. Okay. Another disadvantage is poor overall performance. Okay, because it's requiring a user program, okay, to traverse through multiple layers to obtain OS service. Okay. So the third structure is microkernels. Okay, so in microkernels, it moves as much from the kernel into user space. Okay, so the example of microkernel is Merge OS. Okay, another one is Mac OS kernel, which known as Darwin, that is partly based on Merge. Okay. So microkernel provides minimal process. Okay, it's provide minimal process, okay, memory management, and also IPC. Okay. So communication takes place between user modules. Okay, so this is user modules. Okay, using message passing. So means that when user modules want to interact, okay, they need to use message passing, which is in a different address space. Okay. So the benefit of microkernel, it is easier to extend a microkernel. So if new services are added to a user space, okay, thus it do not require modification of the kernel. Okay, but if the kernel does have to modify, the changes tend to be fewer because the microkernel is smaller kernel. Okay. Right. So the second benefits, more secure and reliable, because more services are running as user, okay, rather than kernel. So if service fail, the rest of OS remains untouched. Okay. It still can be functioning. Okay? OS still can be functioning. The impediments of this structure, okay, performance. It has performance overhead in copying message, okay, because when if you look at this figure, okay, when user modules, okay, want to communicate, they need to copy each other message. Okay, for example, if user program wants to use file system both of them needs to copy message to communicate. Yeah? And then the second one, switching between process, because switching between process to exchange the message. Okay, sorry class. So they need to switching between process to exchange the message. Okay, so this is the performance overhead that's become the major impediments in microkernels. Okay, right. So that's all in OS structure. Thank you for watching.